Hi, students. Let's look at this question here, which is on functions taken from the year 2020 Diamond High School Promo question 3. This is pretty interesting one. So essentially, you're given that both functions f and g are defined as follows, and c and d are constants. Then given that a composite function gf exists, find an inequality involving c and d. I think that's a pretty good one. So the first thing I will usually ask students to do is just roughly sketch out the graph first, because now you have no idea what's going on. So you know that this is, for gx is easier because this is essentially just a long graph. So I would suggest not to use calculator. Understand, as in you can use a calculator to draw, but you really need to understand how this works, which is like gx, like that. Okay, and after which this is like 1 and this is 0, this is y and this is x. Okay, that's pretty okay. So maybe you can just write this as gx. Okay, so this is okay. So from here we know that domain of g is actually just 0 to infinity, of which the range of g is actually a real number. Okay, you just negative infinity to infinity. That's pretty okay. So done with gx. Now the next thing is we need to find what is fx. So fx, it would be x squared plus cx plus d. So what we're gonna do is actually fx equals to x squared plus cx plus d. Okay, now what is important here, this is actually a smiley face. What we need to know is this smiley face here, we need to find the minimum point. So the mean point, you can complete the square. Obviously you can complete the square, so this will be x plus c over 2 square minus c over 2 square plus d. If you want to complete the square, I think completing a square will be quite fast. So this case here would be plus d minus c squared over 4. Okay, so hence mean point would be when x is equals to minus c over 2 and d minus c squared over 4. Alright, that is the mean point of a quadratic function. And since you want the composite function to exist, form an inequality involving c and d, that's pretty okay. So so in other words, right, okay, I'm going to draw this fx graph first. Actually, the fx graph, we know that it will essentially goes through here. You don't really know where this is at, but I'm just going to draw this out first. Then this would be your d when x is 0. The mean point here is minus c over 2, comma d minus c squared over 4. In other words, this is actually d minus c squared over 4. Okay, this is minus c over 2. So this is my fx. That's pretty okay. Fx is here. This is x. So range of f would be from inclusive of d minus c squared over 4 to infinity. Okay, so that's the range. So that's pretty okay. Now, if the composite function gf exists, it just means that range of if gf exists, just means that range of f, the first function, which is f, will be contained in the domain of g. That is the most important part, right? So in other words, range of f would be d minus c squared over 4, comma 0 infinity, right? It has to contain within essentially 0 to infinity. That is the main thing. This here have to contain within here, because what we are doing now is essentially taking the range of f here, and we're gonna substitute inside the domain of g. Okay, so we know in order for this to happen, this has to be bigger than 0. Look at this. So hence this will imply that definitely imply that d minus c squared over 4 bigger than 0. So I think this is pretty okay. What do we want? We want find an inequality involving, so there you go. So this would be d is bigger than c squared over 4. I could just put 4d is actually bigger than c squared. This is a nicer one. So I think this is the answer. Okay, for it to exist. Okay, so that's how we do the first part there.